Assalamualaikum warahmatullahi wabarakatuh and good morning. Today we will continue our chapter on thermodynamics. Now we will be looking at chapter 2.1 on state of pure substance in liquid and vapor. Inshallah, today in this chapter we'll be looking at few topics, which is definition of substance in properties and its properties. We will look at property diagram, which is TV and PV diagram, property table, and lastly we'll be looking at quality, which is X, and enthalpy. Now let's look at pure substance. Pure substance can be defined as a substance that have fixed chemical composition. What does it mean by having a fixed chemical composition is that whether in liquid phase, mixture, or liquid and vapor, or pure vapor state, the composition is still the same. The example of water, the chemical composition of water remains H2O in all phases, whether in liquid, mixture, or vapor phases. There are also other examples such as refrigerant, R134A, CO2, and also air is considered as a pure substance. Now let's look at the state of pure substance. The state of pure substance can be defined by knowing two intensive properties. I hope you still remember what is intensive properties. The intensive properties are pressure, temperature, and specific volume. There are other intensive properties, but this is the main intensive properties that we will be using a lot. By knowing two or from three the intensive properties, we can define the state of our pure substance as whether the substance is in compressed liquid region, saturated liquid region where only liquid existed, saturated mixture region where liquid and vapor exist at the same time, saturated vapor region where only vapor exists, or in a superheat region. Take an example of water as a pure substance. If a compressed water is heated by adding heat, the temperature of water will increase, resulting all the water to change phases from compressed liquid to saturated liquid. And if we added heat again, the phase will change from saturated liquid to saturated mixture. So the mixture consists both saturated water and saturated vapor. If heat is added again, all saturated vapor will change into vapor, which creating saturated vapor. Then if heat is added again, and it will create a superheated vapor. This is the process of changing phases for water if heat is continually added. Reversely, if the heat of water is losing, the water is losing heat, the water will turn back to compressed liquid while undergoing the same process, but the phase will be just opposite at adding heat. Okay, next we will be looking at the property diagram. Property diagram can be divided into two, which is TV diagram and PV diagram. Both diagrams have a bell curve graph. From the properties diagram, we can define the state of our substance, whether it compressed liquid, saturated liquid, or saturated vapor, or superheated vapor. Now, for example, let's take a look at TV diagram. The diagram is temperature versus specific volume diagram. The red line is the bell curve in the diagram is a saturated line. Okay, saturated line. If the saturated line exists in the superheated region, then the line is saturated vapor line. If the line exists in compressed liquid region, then it will be saturated liquid. At the top of the curve is critical point that divided the region into compressed liquid and superheated region. The peak line is constant pressure, where we can define the state of our substance. Now let's look at the phase of pure substance in TV diagram. At point 1, the substance is in compressed liquid. At point 2, it's changed to saturated liquid, where only liquid exists. Between point 2 and 4 is saturated mixture of liquid and vapor. At point 4, it becomes saturated vapor, and lastly, above point 4, the substance is in superheated phase. In this case, saturated mixture, saturated temperature T set is 100 degrees Celsius. Vf is specific volume of saturated liquid, while Vg is the specific volume of saturated vapor. The PV diagram of pressure versus specific volume diagram is the same as the TV diagram. The only difference is that it has constant temperature line instead of constant pressure line. The data of saturated temperature, saturated pressure, specific volume for saturated liquid and saturated vapor can be found using properties table. Alright, the property table that we'll be using is A4, A5, and A6 for H2O, and A11, A12, and A13 for refrigerant R134A. Okay, this is only the two types of pure substance that we'll be using for our class. The use of property table is to use the property table is wise. To draw TV or PV diagram first to determine where is the data can be taken. I hope you still remember on how to take the data as we already discussed it at previous class. If some of you have difficulties in remembering, please refer to Thermodynamic MOC Learning Activity 2.2. Okay. For property tables, from property table, we can define the state of our substance, whether saturated, superheated, compressed, or a mixture. For example, if pressure is smaller, if given pressure is smaller than P saturated, then it will be in superheated vapor. If V specific volume given is smaller than specific volume of saturated liquid, then it is in compressed liquid. Please remember the characteristic as it will be useful in the future class. Next, we'll be looking at quality, which is X. Quality can be defined as ratio of the mass of saturated vapor to the total mass of saturated liquid and vapor. If the quality is equal to 0, the substance is saturated liquid. If quality is equal to 1, then the substance is saturated vapor. Is the value of X is between 0 and 1, then the phase is in saturated mixture. If the phase is mixture, then use the equation to find the specific volume, V. Okay, when V, specific volume Vf equal to, you can use the equation V equal to Vf plus X Vg minus Vf. Vf stand for specific volume for saturated liquid. Vg stand for specific volume for saturated vapor. Alright, and then now and lastly, let's look at enthalpy. Enthalpy can be defined as H equal to U. U is internal energy plus P, pressure, times volume, V volume. If enthalpy is divided by mass, we can get a specific enthalpy, which is the small h. Now that's all for our class today. So for your homework, please complete exercise 2.1 and submit it via Google Classroom. Please don't forget to fill in your attendance in Google form. Okay, alright, thank you for your time, and Assalamualaikum warahmatullahi wabarakatuh.